So now I'm going to demonstrate how to work with 520 byte per sector SAS drives. First thing you need to know is that you have to have a controller that is non-RAID, meaning that your controller must just show the drives as just a bunch of disks. If you cannot work with a RAID controller and clone with HDDSuperClone. So the first thing I'm going to do is create a new project. I'm going to choose the mode, SCSI, pass through. We're going to choose our source drive, which right here is a Hitachi SAS drive. Choose that. I'm going to choose a destination. I could, for this, I'm going to choose an image file because I don't have another drive that I could clone directly to with 512 bytes. So I'm going to say image file. Go here, and I'm going to call it image 520. In theory, everything's ready to go. If you look at clone settings, it has automatically detected that the drive is a 520 byte per sector drive. You can see that in the identify results, which is SCSI read capacity command. That right there is the number of logical blocks or sectors, and here is the sector size. 208 in hex is 520 bytes. So we would do a connect and start, and it is now cloning this drive to an image file with the full 520 bytes per sector. As you can see, our clone rate is just a little over about 42, 43 megabytes a second. Now I'm going to show you how to clone a 520 byte per sector SAS drive to either a 512 byte per sector image or drive. First, we need to choose our source as SCSI, choose our source drive, which is our Hitachi 520 byte SAS drive. Now I'm going to choose a destination of image file, and I'm going to call it image 512. So choosing our source and our destination. Settings, as we can see in our clone settings, it's cluster size for the source or the sector size for the source is 520. That's okay. We need to go to advanced settings, and we need to enable the output sector size adjustment. We need to enable it, and that tells us that we have to close and reopen the settings to be able to change it, because you see it's still grayed out. So we do that, go back into the advanced settings, and we're going to change this to -8. That will trim the last 8 bytes off of every sector, trimming them down to 512 bytes, because that extra 8 bytes is data for the RAID controller. It is not user data. The user data is almost certainly only the 512 bytes per sector. So now that we do that, we will connect and start, and it's cloning at the same rate as before, only now it is trimming every byte off. And I could have chosen another drive, that even a SATA drive that was only 512 bytes per sector, because it is trimming off the unneeded bytes. So now I'm going to show how to write a 520 byte per sector image file back to a 520 byte per sector drive, or the same would apply for cloning a 520 drive back to another 520. If you were cloning a drive to drive, you'd choose your source mode as pass-through SCSI, but since I'm using image file, I'm going to choose generic source file. So the source is going to be my 520 byte image file I just made, and the destination is going to be this Hitachi 520 byte per sector drive. Now in the settings, to go to advanced settings, and we must enable SCSI write to destination for odd sector size. Anytime you're going to write to an odd sector size, it's not a multiple of 512 bytes, you have to enable this because Linux can't do it any other way. The normal mode, I should say, of writing for HDDSuperClone is just using the operating system to perform the writes, and you're limited to multiples of 512 bytes for a sector size. The other thing we need to do is make sure that in our clone settings, see, it still says that the source is 512 bytes because it can't tell when it's an image file. If I would have chosen a drive, it would have automatically changed this, but I need to change this to 520 so it knows that the source is 520 bytes. So every sector that it sends to the disk is 520 bytes. So we should connect, and if I did everything right, it should clone. Now, here's something you'll notice is that the speed is about 1/3 of the speed that it was when reading, and this is an anomaly of the SCSI pass-through writes when writing an odd sector size. There is nothing I can do about that. It just writes slow. So anytime you write to 520 byte per sector drive, it's going to be slower. Either deal with it or use some other software or hardware to do it, because there's no way around it with Linux. So now I'm going to show you how to write from a 512 byte image or drive back to a 520 byte per sector SAS drive in the event that you should need to do that for whatever reason. So because my source is not going to be a drive in this case, I'm going to choose generic source file. My drive is going to be my 512 byte per sector image. Destination is going to be the Hitachi drive. Now, settings. First thing, clone settings. Make sure I'm coming from an image file. Source it's a 512 byte. Make sure that your source sector size is 512 bytes, which it is. Now, in advanced settings, I need to do two things. I need to enable the SCSI write to destination because I'm writing to a odd sector drive, 520 bytes per sector. And I also need to enable the sector size adjustment output. I'll go back in now after I've enabled it to be able to change it. And this time, because we're going from 512 to 520, we need to be a +8 for the adjustment. This pads the end of every sector with 8 bytes to get the 520 bytes needed to write to the drive. And if I've done everything correctly, I should just be able to connect and start. And it is now cloning from an image file that was made for 512 bytes per sector back to the 520 byte per sector drive. As you can see, it's slow again, but as stated, that is a Linux thing when you write into an odd sector drive. It's an anomaly that I can't do anything about.